Hello out there. Thanks for joining us for our Colorado River Basin Water Supply and Peak Flow webinar for April 2023. I'm Cody Mosier, a hydrologist at the Colorado Basin River Forecast Center. So today we're going to start by talking about March weather, precipitation and temperature, and then dive into current snowpack conditions, and then take a look at our April water supply forecast and the water supply forecast air that we typically see in April, and then get into some information regarding our peak flow forecasts, and then end by looking at the weather that we've seen during the first week of April and what we're seeing in the weather forecast, and then we'll open it up at the end and take any questions. We do have staff monitoring the chat box within this webinar, so if you do have a question, feel free to type it into the question box. And this webinar is being recorded, and the recording and the slides will be on our webpage later today. All right, right into the March weather summary. So the weather pattern shifted around mid-February to a cold and wet weather pattern that continued through the end of February and continued all the way through March across the region, with precipitation continuing to favor the entire state of Utah, central Arizona, and northwest and southwest portions of Colorado. And the image in the center there, that's March monthly precipitation percent of average. So generally across the Colorado River Basin, we saw 150% of average precipitation during March. And then when it comes to the temperatures we saw during March, it's colder than normal across the region, and that led to additional snow accumulation across lower elevations. And we didn't see a whole lot of snow melt occur, especially across lower elevations of the upper Colorado River Basin. So again, the graphic in the middle, percent average precipitation. Notice a lot of dark blues into the purples, indicating greater than 150% average precipitation during March. And then the image on the right showing the maximum temperature departure from normal, with the blue colors indicating below normal temperatures across our entire forecast area. And just real quick, looking at some SNOTEL stats covering the March 2023 precipitation. So this graphic here is from the NRCS, and this is showing 1 month record precipitation during March across the region. So any blue dots you see, that was a SNOTEL station that recorded the record March precipitation. So lots of blue dots, and the green dots indicate the second highest precipitation. And these pretty widespread across the upper Colorado River Basin, the White Yampa, you'll notice in northwest Colorado, the Sierra Madre Range up there, the Duchesne River Basin around the Uinta Mountain Range area, down into the south central Utah, lower Green area, and then southwest Colorado, the Gunnison River Basin, down into the San Juan and Dolores River Basins in far southwest Colorado. And in the lower Colorado River Basin, SNOTEL stations reported near record March precipitation in the Virgin River Basin in southwest Utah, as well as the higher elevations in central Arizona around the Verde and Salt River Basins. So a very wet March across much of the region with these SNOTEL stations. Generally wettest 3 on record in a lot of these areas and above the 90th percentile. And then here we're summarizing Water year precipitation, so this would be October through March. The table on the left, you'll see a few of these during the presentation. These tables are broken down by major river basins, so Upper Colorado River Basin, and then you'll see some sub areas within the Upper Colorado River Basin, and then the Lower Colorado River Basin on the bottom there. So the middle column would be the March percent of 1991 through 2020 average, or March precipitation compared to that average value. So big numbers, again, most of them greater than 150%. And then looking at the water year to date, the last column, October through March, above average in the majority of the region, with the exception being parts of the Colorado River headwaters. So this area circled in red here, as well as the far northern Upper Green River Basin. Those areas have seen less precipitation compared to surrounding basins this season. But overall, really strong water year precipitation to date. Now into snowpack conditions. The image on the left, this is showing April 1 snow water equivalent conditions, otherwise known as SWE. It indicates the amount of water that's in the snowpack. So image on the left here, the squares are those NRCS snowtel stations. Those are SWE observations, and those are overlaid on our hydrologic model significant runoff areas. So again, lots of blues, purples, greater than 150% of normal across most of the region. And then the table in the middle here, this is showing the snowpack conditions on March 1st and on April 1st, and then the trend. So all areas, in this last column here, positive values indicating snowpack as a percent of normal increased during March. And again, some of those areas that receive more precipitation, Yampa White, Duchesne, Price and the Lower Green basically saw larger increases. They had a wetter March with snowpack in those areas, top 5 wettest, generally above the 90th percentile. And then as you move down into the headwaters of the Colorado River, which saw less March precipitation, there were still some increases, but they were smaller. And then down in southwest Colorado, some pretty large increase in percent normal snowpack conditions over the past month down there, with the April 1 snow water equivalent at most of those snowtells in the San Juan Mountain Range ranked in the top 5 wettest and above the 90th percentile. And then in the lower Colorado River Basin, central Arizona snowtells, they're typically near meltout, around 0 by this time of year, and that's not the case this year. We're seeing near to record April 1 SWE in central Arizona and southwest Utah. So just to summarize, early April snow water equivalent conditions range from slightly above normal to near record across the Colorado River Basin. And here, just another way to look at some of the snowpack statistics out there. These are at snowtel stations that are out there reporting observations, generally higher elevation stations. On the left, the percentile, and this is April 1st, basically end of the day on March 31st. So you can see, looking at the percentiles, anything with 100 is record SWE at that location of April 1st, and then on the right, this would be the max ranking. So again, very easy to see on these graphics where the snowpack is near record and doing better than, say, the upper green and that section of the Colorado's western slope, kind of the Colorado River headwater areas. Not quite doing as well, but the majority of the areas, again, above that 90th percentile and generally top 3 or top 5 at a lot of those locations there indicated with the dark blue circles. And now looking at the snow distribution, here this is the high elevation versus low elevation look at snowpack conditions out there. So graphic on the left, similar to one that was shown earlier. Those squares are those snow-tail stations that we have observations for, and then our hydrologic model areas are the shaded areas. So on the graphic on the left, this is showing the areas that produce a significant amount of runoff to the upper Colorado, well, to two streams, and then the graphic in the middle, this includes all runoff areas from our model. So you can see just the amount of low elevation snowpack that's out there and how it's looking as a percent of median. It's generally greater than 200% across those lower elevations. And we do model areas above and below those snow-tail stations in our snow model. So some of the implications when it comes to snow distribution, the timing of the snow melt, the inflows into some of those higher elevation reservoirs, and then the snow distribution has an impact on peak flows, and of course the impact on the April through July runoff volumes. And just to note, so we're not showing on these maps areas where the median SWE is 0 this time of year, but it does give you a good picture of kind of that high elevation versus low elevation snow that's out there. Okay, now right into our April 1st water supply forecast for the upper Colorado River Basin. So our water supply forecast volumes increased over the past month as a result of that above normal March precipitation. So this is graphic in the middle, just summarizing the entire upper Colorado River Basin, broken down by sub-basins. So again, starting here in the upper green, the lighter greens, legend here on the left, not doing quite as well as areas to the south, such as the Duchesne and Lower Green River Basin and the White Yampa River Basins in far northwest Colorado, near the Wyoming border. And then continuing to move south across western Colorado. Again, the Colorado River headwaters kind of in a similar situation to the upper green, a little bit lower forecast as a percent of average. Haven't seen the high precipitation amounts compared to some of the surrounding areas. And then as you move south into Gunnison and southwest Colorado, you start to see water supply forecasts that look better as a percent of average. And then at the bottom of the upper Colorado River Basin here, Lake Powell, April 1st water supply forecast there is 177% of average. And that's the percent of the 1991 through 2020 average. So that Lake Powell number, good value to look at, summarizes the hydro conditions throughout the entire upper Colorado River Basin. And now taking a closer look at our Lake Powell April 1st water supply forecast. So this is our water supply forecast evolution plot. That'll spend a little bit of time going over. So we're plotting on the y-axis the volume in thousands of acre feet, also known as CAF. And then the time is along the x-axis. We run our model daily. We start publishing our water supply guidance around mid-December, which is The blue line here, you can follow that to see how that's trended over the year. And you can see we started out mid-December, we were below average here. And then as we've seen precipitation, above average precipitation over the winter above Lake Powell, the forecast has trended up. And during March, again, a very wet March led to substantial increase in the water supply outlook at Lake Powell. So these water supply forecasts are probabilistic. So we provide a range of values. I'll start with the pink dot in the middle here. This is our official water supply forecast for April 1st. So this is the volume that has a 50% chance of being exceeded and a 50% chance of not being exceeded. And that value is 11.3 million acre feet. Again, that's 177% of average. So you can see the range of values here. So this, this pink dot on the top, this would be the volume that has a 10% chance of being exceeded. So this would be a wetter spring weather scenario. And then the pink dot on the bottom, this would be the volume that has a 90% chance of being exceeded. This would be indicative of a drier spring weather scenario. And there is a 20% chance of the observed runoff being above the 10% value and below the 90% value. So something to keep in mind there. And then we also show, now that we're in the observed period, April through July is what we're forecasting. So this is how inflow into Lake Powell, this dashed brown line here, this is how it typically accumulates. You can follow that up to the average line there. So here, again, trending much above average, a large increase during March due to the significant precipitation that we saw during March. And then here, focusing in on the green, Yampa White, and Duchesne River Basin water supply forecast. I'm not going to go over all of these numbers, but you can find your favorite location there. We're showing the April through July volume is the number on the left, and that's in thousands of acre feet. And then the number on the right in these boxes here, that's showing the percent of the 1991 through 2020 average. And again, upper green, not doing quite as well, although still near to above normal water supply forecast there. And then as you move into the Duchesne and the White Yampa, conditions quite a bit better in those basins. We do list some values here. So upper green forecasts, these green shaded areas here, 95 to 145. And then the Yampa White, 135 to 210 is where those forecasts are ranging as a percent of average. And all of these forecasts did increase from March forecasts. So looking at the Flaming Gorge Reservoir in the Upper Green River Basin, looking at the water supply forecast evolution plot here, you'll notice this area kind of been or started near below average December through March, and then you can see it's the water supply volume guidance and forecast has trended upwards due to that wet March, and into early April has been quite wet up there as well. So that has increased the water supply outlook above Flaming Gorge Reservoir in the Upper Green River Basin. We're forecasting 1,200 CAF, or 124% of average. And now into the Upper Colorado River main stem. So up above Kremling here, water supply forecast range 90 to 150% of average, and that increased up to 20% from the March forecast. And then in this lower section, Kremling to Cameo, water supply forecast ranging 95 to 120% there. And now looking at Dillon Reservoir in the upper Colorado River main stem headwater area, looking at the water supply forecast evolution plot. So this is one of those areas that it's kind of been around average, kind of slowly declining to below average. It just hasn't seen the precipitation that many of the other areas have, and that's certainly reflected here in the water supply forecast evolution plot. Forecasting 150,000 acre feet into Dillon Reservoir, which is 90% of average. And now into the Gunnison and Dolores River basins. Gunnison, April 1st water supply forecast ranging 110 to 225% of average, with up to a 75% increase there due to the wet March. Pretty similar story in terms of the up to 75% increase in the Dolores River basins. And our April 1st forecast in the Dolores ranging 140 to 210% of average. And into the San Juan, our forecast 135 to 200% of average, which was a 25 to 35% increase from our March water supply forecast in the San Juan River Basin. And a little bit closer look at our water supply forecasts and snow conditions in a couple areas in southwest Colorado. So along the top here, this is in the Gunnison River Basin above Blue Mesa Reservoir. You can see how the water supply volume guidance has trended during the year. Again, a big March there, so substantial increase in the water supply forecast from a month ago, with forecast in the Blue Mesa 850,000 acre feet or 134% of average. And in the upper right, we're showing a graphic related to our model snow conditions above Blue Mesa Reservoir. So there's two lines plotted here. The blue one is normal snow accumulation and melt trace, and then the black trace is this year. So with March shaded here in that lighter gray, so you can see how the snowpack, how much it improved during March above Blue Mesa Reservoir, with the model SWE up there around 160% normal as of April 1st. And then down along the bottom, looking at the Dolores River Basin, this is McPhee Reservoir. A pretty steady increase since January above McPhee Reservoir. Significant increase during March with our water supply forecast there. So we're showing about a 50% chance of near record volume. And that's assuming we see near normal April through July weather. And the snow plot on the bottom right above McPhee Reservoir for our model snowpack. There's a couple traces plotted on here. Again, that blue trace is normal. The black trace is this year, and then we're also showing a couple analog years, 2019 and 1993. So back on March 1st, our model snowpack was in between 93 and 2019, and as of April 1st, it's above both of those traces, sitting at 238% of normal as of April 1st. Now down into southwest Utah, this is the Virgin River Basin. We only have a couple forecast points here. They're ranging 260% to 350% of average. The Virgin River Basin had a very wet March. You can see just a significant increase in the water supply outlook during the past month there. And then the snow plot on the bottom right. This is not model snow, but this is snow at NRCS snow-tell stations in the Virgin River Basin. The magenta trace would be the normal here, and the blue trace is this year, which is currently right around where the snowpack was back in 2005. And something to note here in the Virgin River Basin with this forecast, we're showing about a 30% chance here. This dot that I'm hovering around, about a 30% chance of seeing the max volume. Again, that's 2005, which is shown down in the snow plot on the bottom. And then finally, down into the lower Colorado River Basin. So in the central Arizona, down kind of towards the Arizona-New Mexico border, these water supply forecasts are January through May forecasts. And we compare these to the 1991 through 2020 median value. So a little bit different than what we show and forecast for the upper Colorado River Basin, but conditions down there extremely high. All these indicating dark blues 200% or greater across the lower Colorado River Basin in Arizona and New Mexico. You can see the ranges there, pretty large numbers. There were multiple atmospheric rivers that led to well above average precipitation across Arizona in March. Okay, now here we're looking at historical forecast verification when it comes to our April water supply forecasts. The graphic on the left, this is the percent forecast error associated in our April forecasts, and some sites listed in the table. Generally about 15 to 20% error in our April 1st water supply forecast, with future weather being the primary source of water supply forecast error uncertainty. Or put another way, the uncertainty in the future weather plays a bigger role in the forecast error compared to our hydrologic model states, such as soil moisture and snowpack. So where our forecasts are better are typically those headwater locations that are primarily driven by snowmelt, and we have a good handle, and there's gauge information that lets us know about some of the diversions and demands that are taking place. And we don't do quite as well in those lower elevation areas where we can see rain or early melt, in those areas that are downstream of diversions. There's not a lot of real-time gauge information that we can use in model. Okay, now into our peak flow forecasts. So we typically do a peak flow forecast webinar around middle of March, but it didn't happen this year just due to the big snowpack across the lower Colorado River Basin. We saw rain and snow, rain on snow melt, so we're quite busy with forecast operations. So we're providing that information here. So just a little bit of background information about our peak flow forecasts. So our mean daily peak flow forecast points are a subset of our daily river forecast points. So we provide Daily river forecasts, those are 10-day stream flow forecasts. Those are deterministic forecasts. And then I just covered our water supply forecast, and now we're into our peak flow forecast products. So our peak flow forecasts represent a long-range outlook of peak flows due to snowmelt. And many of these sites have established flood stages and can therefore provide some information about the flood threat. And the peak flow forecasts have a high level of uncertainty because they're highly dependent on spring weather. We do not forecast a specific date of the peak flow, as we typically only have a 5 or 10-day forecast lead time due to just it being highly dependent on the weather pattern in the next week or two. So we don't forecast the specific date of the peak, but we do provide the peak flow timing window that we normally see. So we provide mean daily peak flow forecasts as well as instantaneous peak flow forecasts. And the instantaneous peak flow forecasts are only available for those locations that have a strong correlation with the mean daily peak flow, as well as a long historical record. So if you have a site that has frequent heavy rain, you're not going to get a great relationship as we are forecasting peak flows due to snowmelt. And the bottom bullet point here, peak flow forecast points alone are not a comprehensive summary of any flood threat. So there are many areas out there that we don't forecast peak flows for. So our peak flow forecast points, again, not a comprehensive summary of the flood threat. All right, now just getting into accessing our peak flow forecast information. So here we're showing our web page. We have a drop-down peak flow menu. If you click on the forecast map, on the drop-down there, you're gonna see a map that looks like this. So this is a map view of our peak flow forecast points that are issued daily. And these are points, locations that have minimal upstream regulation. And we provide 3 map layers or variables. So one is percentile, and then we also provide the percent average of the peak flow compared to the what we typically see. And then another layer that we provide is the National Weather Service flood stage exceedance probability. So you'll notice the map in the middle, and then the options on the right, as well as corresponding legend. So here we're looking at percentile, and then we have these help buttons here, looking for more information about what each of these layers represent. If you click on a point, you'll be taken to that location's peak flow dashboard page, which we'll get into here in a few slides. So starting with the percentile map view layer. So the percentile represents the percent of historical annual peak flow values that are below the current peak flow forecast. So again, percentile is selected, and the legend is representing the percentile categories. So peak flow forecasts with the higher percentile correspond to locations with better snowpack conditions. So you'll notice those areas that have extreme near record snowpack conditions, the peak flow forecast corresponding to those areas generally above the 90th percentile. So we're seeing that in the White Yampa River Basin, in the Duchesne River Basin, in northeast Utah, and then down along central Utah, Lower Green area, and then again, southwest Colorado, Gunnison, Dolores, San Juan River Basins, as well as southwest Utah, the Virgin River Basin. Those areas have the best snowpack conditions, as we talked about earlier. So peak flow forecast there, generally above the 90th percentile at a lot of those spots. And now looking at the percent of average layer on the map. So the legend here, you'll notice a change. This is indicating the percent of average. So the peak flow forecast percent of the 1991 through 2020 average peak flow. So peak flow forecasts with a higher percent of average correspond to locations with better snowpack conditions. Not surprising there. And again, those same areas, you'll focus in on the dark blues and the purples. Those are peak flow forecasts that are greater than 150% of the average peak flow. Again, White Yampa, Duchesne, down into the Virgin and Southwest Utah, as well as the Gunnison, Dolores, and San Juan River Basins. So another way to look at our peak flow forecasts, percent of average layer there. And then this last option here, this is the National Weather Service flood stage exceedance probability. So this is the probability of the peak flow forecast exceeding the flood stage at that location. So the legend indicates the exceedance probability. So peak flow forecasts with a higher exceedance probability correspond to locations with increased flood potential. And here, just looking at the red dots, a couple in the White Yampa River Basin as well as the Gunnison, and there are quite a few gray dots here, so not all locations have an established flood stage, and those sites are indicated in the gray diamonds there. Again, clicking on any one of these points here will take you to the site's peak flow dashboard page. So let's take a look at what those peak flow dashboard pages look like. So this is a location in the Gunnison River Basin, the East River at Almont. So this is the peak flow dashboard for that location. So you'll notice peak flow dashboard pages have a lot of information as well as a couple different plots. So just starting in the upper left, so we're showing, this was grabbed yesterday from our model run. It provides information, the flood flow, our 50% peak flow forecast, the ranking, the percentile, the average peak, the percent of average that the current peak flow forecast is, the normal time that this location typically sees its peak flow, as well as information about last year's peak. So last year's peak occurred, looks like about a day earlier than the normal window. And then you can click on this graphic in the upper right. It's got a similar look and feel and behavior to our water supply forecast evolution plots. They're interactive. As you hover over the plot, your legend will change up here. We were plotting instantaneous flow here. So we were ice affected, and then we're now showing observed flow there from the USGS. And you can see how the peak flow forecast here has trended upwards as we've seen more precipitation over the last couple months. And another thing provided on the peak flow dashboard pages is information related to our 10-day stream flow forecast for that location. So our hydrograph on the bottom right, this is what our 10-day stream flow hydrograph product looks like. So we're indicating the blue is observed, and then the green is our forecast, indicating some snow melt in the forecast here. So the 10-day streamflow forecast plots, great for just staying aware of the situation, because flows could exceed flood stage prior to peak flow. So good tool to use. So as the time of the peak nears, we recommend transitioning from using our probabilistic peak flow guidance to looking at our 10-day streamflow forecast to get a little bit better picture of what's coming. So our 10-day streamflow forecast, we use the 7 days of the precipitation forecast for the next 7 days, and the temperature forecast for the next 10 days are what goes into our 10-day streamflow forecasts. And all of this information also provided on each location's peak flow dashboard page. So we provide tables showing the probability of certain peak magnitudes and the probability of the peak dates. So these tables are independent forecasts. So the probability of the peak date would be the likelihood for the date of the peak flow, whatever the magnitude may be. And we're also providing information about historical peaks in table form. As you can see, historical peak flows and the rankings, as well as model snow conditions for that location, which I'm not gonna get into, but again, you can click on the graphic. It'll take you to an interactive plot where you can find out more information about the snowpack conditions in that particular basin. So all of this information on the peak flow dashboard for each peak flow forecast location. And we also have a list view option for viewing our peak flow forecast information. So again, on our webpage, peak flow dropdown forecast list, it'll bring you to something that looks like this table on the bottom here. And we do have some data filter and sorting options available on the list page. Here I am looking at peak flow forecasts in the Green River Basin. So this would be Upper Green, Yampa White, Duchesne. This is not the full list, but these would be all the sites that we provide a peak flow forecast for in the Green River Basin. And again, clicking on one of these links here will take you to that site's peak flow dashboard page. Lots of information here, historic peak, the window, ranking, flood flow, bunch of information there that you can look at. Okay, so we do provide some special peak flow forecast products. So again, peak flow drop-down menu, we have a link for the special peak flow forecast map. So this map includes main stem river locations, and these locations downstream on the main stem of rivers, generally there's a lot of upstream water management that takes place, and that impacts flows downstream. So this could be upstream reservoir operations or diversions that take place upstream that impact what flows occur downstream. So these forecasts, they require a bit more forecaster involvement. They're not updated daily, generally updated twice a month. So a couple examples of our peak flow forecast products would be this location here. This is Cameo on the Colorado River main stem. So this is a site that gets looked at and used when it comes to the peak flow forecast. And there are years in which the peak flow gets augmented if the conditions are right, if there's enough water to do so, and it basically requires real-time multi-agency coordination between the Bureau of Reclamation, Denver Water, lots of others, U.S. Fish and Wildlife Service. So these points just take a bit more time, a bit more forecaster knowledge and intervention just due to those upstream reservoir and diversion operations. So require a bit more looking at as opposed to just pushing something out daily from our raw, just hydrologic run for the day. So I mentioned the Colorado River main stem, another example, the Gunnison River Basin. They have some downstream peak flow magnitude and duration targets there, and those can be based on the type of hydrologic year, dry, average, wet. So again, just a bit more involvement when it comes to issuing these special types of peak flow forecasts. And we do not forecast peak flows across Arizona, but we thought this would be interesting to look at with some March observed peak flows that we saw at a couple points. So in the Verde River Basin, you can see these are our 10-day stream flow forecast hydrographs that I mentioned a few times. We show observed and then our forecast here, but the focus here should be on the peak flows that we saw in March. So in the Verde River Basin, we saw a peak of around 100,000 CFS due to just the very active big snow, rain on snow, rainfall runoff that occurred during March across central Arizona. And that was also the case at a number of basins. So stepping down to the bottom left, this is in the Agua Fria River Basin, saw about a peak of about 24,000 CFS above moderate flood stage. And then in the Little Colorado in the upper right, near Winslow, about 12,000 CFS peak there, just above moderate flood stage. And in the Salt River Basin, saw about 29,000 CFS peak there. All right, now moving into the weather that we've seen during the first week of April. So this is looking at April 2023 month-to-date precipitation. So early April precip continued to favor or has favored northern Utah. So when it comes to the upper Colorado River Basin impacts, that would be the Duchesne River Basin and southwest Wyoming, the Upper Green River Basin, and then northwest Colorado, and even a little bit down in the Virgin River Basin in southwest Utah. And you can see the table on the right, how snowpack has changed just during the first week or so of April. Not a lot of changes, but encouraging to see some increases there just in the first week of April. All right, now into the weather forecast that we're looking at. So this is showing the 7-day precipitation forecast on the left from the Weather Prediction Center. And so we're currently seeing a ridge of high pressure over the western US, and that will bring a period of dry and warming conditions to the region. The temperatures are expected to be around normal by this weekend, and even about up to 5 to 10 degrees above normal to start next week. We're not expecting to see any precipitation now through the middle of next week, so a bit of a break. And then during the last half of next week, this ridge looking like it's going to begin to break down as a trough moves into the western US. So at this point, there's high forecast uncertainty in the depth and the timing of this trough. Current weather model guidance is favoring precipitation across Great Basin, Utah, basically, as well as upper Colorado River Basin. Little or low chances of precipitation across the lower Colorado River Basin. So currently dry and warming now through the middle of next week, and then we're expected to cool off and see some precipitation late next week. And beyond that, ensemble models are favoring another ridge building in. So that's what we're seeing for the next week. And then looking out a bit further, so this is the 8 to 14 day outlook. So this would be spanning April 14th through the 20th. These graphics are showing the probability of above or below normal precipitation on the left. So there we're seeing near normal precipitation being favored for much of the western US in that 8 to 14 day outlook, with near, maybe a little bit below normal temperatures across the region. Again, this is that April 14th to 20th timeframe. So just to summarize here, starting with soil moisture conditions, which we didn't talk a lot about today, but our model soil moisture conditions across the upper Colorado River Basin, those are near to below normal across many of the major runoff producing areas across western Colorado up into southwest Wyoming. The current soil moisture conditions in the lower Colorado River Basin above average. They've been very wet, rain, snow melt down there, significantly improving soil moisture conditions across Arizona and western New Mexico. March weather was cold and wet, generally above 150% of average across most of the Colorado River Basin. It was cold, much colder than normal, so we had additional snow accumulation across the lower elevations with little snowmelt occurring. Snowpack conditions as of yesterday in our model across the upper Colorado ranging 120 to 250% of normal, and above 250% of normal across the lower Colorado River Basin. Our April 1st water supply forecast in the upper Colorado, 90 to 260% of normal, with Lake Powell being at 177% of normal. And lower Colorado, January through May water supply forecast greater than 200% of normal. Peak flows expected to be well above average across the majority of the upper Colorado River Basin due to the big snowpack that's out there with elevated flood potential in those areas. The weather outlook, warm and dry, expected for the next 6 days or so, and then expecting cooler, wetter weather in about a week. And then it looks like maybe another warm up. The water supply webinar schedule listed here. We do host a Utah Great Basin webinar similar to this one. That'll be later today in about a half hour. And then our next Colorado River Basin water supply briefing is Friday, May 5th, the 10 a.m. time slot. This information is on our webpage, and you can access it, dropping down the news. There's our webinar page. You can click on a link to register. You can, if you're interested in receiving some emails whenever we issue forecast products or discussions, you can request to be on one of our email lists. And then again, you can find this recording and slides here on our presentations page. So you can access the PDF or a recording or a YouTube link if that's more convenient. And here's how you can get in touch with us and the basin focal points that are forecasting which basins this season. So we encourage you to reach out if you have any questions. The CBRFC operations is a good place to pass along any information or questions that'll get directed to the right people. So again, if you have a question, please reach out. And I think that's all I had. So I'm going to stop there. We have a few minutes for questions. Just scan the chat box here, and you can also raise your hand and be unmuted if that's more convenient to ask a question. All right, seeing a question from Brandon. We're getting you unmuted here. All right, Brandon.
Can you hear me?
Yes.
Great. So I'm wondering, going back to soil moisture and other conditions that affect runoff, I'm just remembering recent years where reasonably good precipitation didn't turn into good runoff, and I'm wondering how conditions differ this year if they do, whether you would expect that same phenomenon to be a problem this year.
Let's see. Try to do this on the fly a bit. So I know we usually talk about our soil moisture, but didn't have time to. So this is on our webpage. This is looking at the fall soil moisture conditions. This is back early November 2022. So this is looking at percent of average soil moisture conditions in our model. This is percent of average. So you'll notice most areas across the upper Colorado River Basin, those oranges, yellows, reds, so that's indicating near to below normal soil moisture conditions. So when you have below normal soil moisture conditions, it is going to impact your runoff efficiency. So some of that runoff is going to infiltrate into the soils and fulfill those soil moisture deficits earlier on in the season before running off into the streams. So that is expected to have a negative impact on our volumes that we'll see compared to, say, if we had much above or say much above normal soil moisture conditions. So we are expecting those. Those are in our model, so those are directly included in our water supply forecast. So our water supply forecast take into account our soil moisture states in our model as well as the snowpack conditions. I would imagine, some of those areas that just have exceptional snowpack conditions, that's going to outweigh those soil moisture impacts. But again, both of those are included in our model and therefore included in our water supply and peak flow forecasts. We also show how soil moisture conditions change from year to year. So this is showing Improvements, again, we've had a couple pretty good monsoon seasons. Last year was a good one too. So the areas that saw a lot of that monsoon precipitation, the soil moisture conditions improved from a year ago. So that was true, especially around the Arizona, New Mexico border. Utah, soil moisture conditions worse off than Western Colorado. But again, Utah has a bigger snowpack now. So, you know, that's what's out there. Does that help?
Yes, thank you.
All right. All right. Stay on for some more questions if there are any. Looks like Tony typed one into the chat box. So since the percentiles and evolution curves are heavily biased by extended drought conditions, do you have percentiles, evolution curves compared to record snowpacks like 1983, 1984? I think such data may be more relevant to what 2023 has to offer. So let's see, extended. So I would say, just the past 3 years, just the very dry 3 years. So 2019 very wet, and then 2020, 21, and 22 dry. Again, those conditions when it comes to say our soil moisture, we run our model every day, so those are reflected in our hydrologic model states. The wetting and drying of the soils. I'm not sure what else to say about that, Tony. If that didn't help you out, please reach out for more info. Okay, we're a few minutes over and I'm not seeing any more questions, so I'm gonna go ahead and wrap this up. Thanks for attending. We hope to see you next month.